Hey guys, this is Mitch with 5 Point CGI, and today we continue our horror game tutorial series by adding in a basic enemy AI. So we go through the process of building out our enemy, then we go in and we code a basic state machine, and then we create our spheres of detection and influence, and we finally build out our logic to chase after the player and finally patrol and hunt after the player. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we have to do is we have to design out our code. And the best way to do that is kind of by basically boxing out our code and just basically saying how we're going to build this. Now, if you don't want to do this, that's totally fine. You can just go to the next time code and that should jump you right into Godot and get us started with coding. But generally, I like to plan out our code and box it out and make it, see how we're going to go about building this before we actually go and build this. So when we approach our enemy AI, we need to use a state machine. And the reason why we want to use a state machine is because it's going to really segment out our code. It's going to make it so that our code can be reusable, it'll be nice and organized, and we can have stuff set up in specific states. Right? So we could say all of our patrol code is when we are patrolling, all of our wait code is when we are waiting, and we're not messing with any Booleans or anything like that. Now, with our states, what we're going to have is we're going to have 4 states. We're going to have patrol, at least for this tutorial. We're going to have a wait. We're going to have the hunting state. And then finally, we are going to have the chase state. Now I'm going to click on these guys. I'm going to come up here and I'm going to go to text and I'm going to click on this little icon right here. That will allow us to snap this up here. So we'll just do this like so. And let's come in and concentrate in on our patrol state. Now our patrol state is going to be pretty simple. It's going to use the Godot navigation system, so the Godot 4 navigation system. And how it's going to work is first, it's going to get its waypoint. So get next waypoint, and then it's going to grab its direction. So we'll drag this guy out like this and connect it, and we'll say get direction. And then we're going to set our velocity, okay? Because we need to set how fast we're moving. And then we'll move towards our point. And then we have a decision to make. And that's what this little diamond here is for. Okay. So these little boxes basically inform us of what's going on, right? What we're going to be doing. These little arrows say we're going to get our waypoint, then we're going to get our direction, then velocity, then we're going to move. And then we're going to use this little diamond to make a decision. Am I at my point? Question mark. If I am at my point, then I'm good to go. I don't need to continue doing anything, so I can just drag this guy in here and say, I'm done. And we're going to be moving into a wait state. So we'll just go to a wait state. Now, when we go to our wait state, we're going to need to go over and basically look around and wait for our move to our next point once some time has passed. That means that we're going to need a timer of some kind. So we'll just drag this guy down here and just say set wait timer. And we'll drag this guy into here, and then we'll drag this guy up and get rid of that. So basically what we're going to do is if we are at our point and we are good to go, we're going to set our wait timer. We're going to wait, and then we can clear from there, right? We're done. But if we are not done with our movement, then we can get our next waypoint, just like that, okay? So that's pretty much all we need to do for our patrol state. So I guess since we have our wait state here, let's head over to our wait state right here, and let's basically build it out. So the first thing we have to do is when we move into our wait state, we have to stop our movement. And then we need to look around. Okay. And we may or may not get to looking around in this specific tutorial, but we at least will be able to get our stop movement and things like that going. Now, if we drag this guy up and let go, that will drag this up and say this is the way we're moving. So you'll see that we are going in a perfect circle, right? So this would never end and our wait state would never end. Okay. So what we'll do is we will have a signal called wait timer has finished. And in the previous GD version of this, we decided that we were going to use an ellipse, this guy here, to actually denote signals. So we'll have that. So we'll say wait timer has finished. And then we'll drag this guy here. And what's going to happen is when the wait timer is finished, we're going to set next destination. And then we are going to change our state back to patrol because we didn't see anything and nothing happened. Awesome. So now that we have our wait state, what's our next big state? And that is the hunting state. And the hunting state is basically when the enemy starts moving after the player just a little bit, nothing crazy. He doesn't like chase the player down or anything, he just kind of heads in that general direction. Something tipped him off and made him say, hey, I want to go there, right? So the first thing it's going to do is it's going to see if it can actually see the player. So it's going to raycast to player. And then it will start moving towards that player. If it hits the player, it will move towards the player. And then it's going to go ahead and get within a distance of the player. So it's just going to kind of walk up towards the player, but not directly on the player. And it's going to look around for that player. And then we might not have time for this in the tutorial, but it will look around the area for the player. And then we're going to have a choice. If it looks around the area, if it sees the player, what's it going to do? So find player, and these little diamonds, you always want to make sure you have a question, right? You're trying to answer a question. And if it didn't find the player, then what's it going to do? It's going to go back to patrol state, right? It says, you know how video games has this thing called barking, right? Where they say, I didn't find anything. And then they move back to their normal patrol state. That's basically what we're going to do. So return, change state to patrol. And then if it does find the player and it does see the player, then it's going to change state to chase because it now knows the player's there. So it's going to run after the player. It's going to chase it and try to kill the player. And since we just finished up our hunting state and we have a chase state, let's fill out our chase state. So when it chases the player, first it's going to raycast the player to see if the player is actually, in the enemy's vision. And then it's going to come in here and it's going to set destination to player. It's going to change speed to sprint. And then it's going to chase after the player. So it's going to basically do the same code that this guy has up here. It's going to do all of that down here. So it's going to chase after player. And then we'll say catch player. So did we catch our player? If we did, and we probably won't have time for this, but we will attack the player. We'll do that. We'll do this. And if we didn't catch the player, then we have another decision to make. Has player left my range? If he has, then I'm done, right? Set state to patrol. And if I haven't left his range, then I'm going to set my destination to player. And I'm going to chase after that player. And I'm going to try to attack him until I get within his range or he has left my range. And there we go. And that's basically the gist of how we can build out a very simple enemy AI. Now, I know what you're thinking. Okay, but how do I get to hunting state, right? You have a patrol state, you have a wait state, you have a hunting state and a chase state, but how do you actually get to the hunting state? And that's where events will come in. And we're going to do this by doing what's called a rings of detection method of AI. And how that works is if we come up here and I drag in a circle, okay, we'll have an inner circle here. And this inner circle is going to be the small little circle that we use to detect enemy, okay? And what it is it's basically a close hearing circle here, okay? And then if I drag in another circle and I make it just slightly larger or quite a bit larger, depending, and I send this to the back and I kind of adjust this a little bit, this is going to be the far hearing, okay? And if I select this guy and I go to text and I put it to the top, that's basically how we're going to do it. So what's going to happen is if a player gets within this ring, we're going to set state to chase because we are now in that section. If we enter into here, we will set state to hunting. He has heard us because we are within the far hearing stuff. If we're not sneaking and we are in the far hearing ring, then we're going to chase after the player. So basically you can hear the player and you're going to investigate, and here you're going to, if the player's close enough for close hearing and they make enough noise, you will immediately be, I'm going to chase the player. And same goes for hearing. So if we drag out this little triangle here and we make it about, yay big, nice and large, we're going to have a triangle here, and we can say far sight set state to hunting because I saw the player. And then we also can drag in a much smaller cone, throw it on top, and say close sight set state to chase, because we know that our player is right in our view cone, if that makes sense. And that's basically how we're going to approach this, is if they get within the far hearing and they are not sneaking, then we can start hunting them. If they get within the close hearing and they are not sneaking, then we chase them. And same thing, far ring for our sight, we'll hunt them. Close ring, we will chase them. So now that we have this all kind of planned out and figured out, let's go ahead and build this. All right, now the first thing we need to build is our scene for our enemy. So let's come up to our scene, let's click new scene, and let's create a 3D scene. Let's go ahead and double click on our node 3D and let's name it enemy. And then we're going to right click our enemy. We're going to come down and click change type, and we're going to change the type to a character body 3D. And if you're like me and you're from Godot 3, Godot 4 has renamed the kinematic body to character body. So that's just something to keep in mind. I know I've already covered this in the previous one, but just in case you guys didn't see that one, basically they just renamed it for us. Now we need to be able to see what we have. So we're going to right click, add in a child node, and add in a mesh instance, and that's going to allow us to actually add in a mesh, and we need to describe that mesh. So let's come up to our mesh and let's go down to our capsule mesh, and we'll add in a small capsule mesh. Now we're going to drag this guy up just like that, and I need to pull it just a little bit higher. There we go. Something like that will do. And then we need to describe some kind of collision, because everything that's a character body needs to have collision, or else it doesn't interact with the world, right? So you can't just walk up against a wall or really stand on the ground without collision. So let's right click our enemy. Let's add in a child node, and let's add in a collision shape 3D. And then we'll come over here to our shape. We will set our shape to a capsule shape. We're going to drag this guy up to match our mesh here. And then we should probably right click our enemy and let's attach a script. And then we're going to name it enemy CS. That's fine. And for template, we don't really need to use character movement. We'll just do node and hit create. Now, Visual Studio will load for you if you have Visual Studio. If not, VS Code should load for you. And I'll pull this down a little bit so you guys can actually see it. And right now, we're not going to do actually anything in here, because for us to be able to actually move our character, we are going to need some form of navigation. Now, I'm going to click on my Mesh 3D instance. I'm going to Control D to duplicate it, and I'm going to rotate it along the x-axis 90 degrees and give this guy a nose. And the reason why I'm giving him a nose is because in the future, we're going to need to know which direction he's facing. Now, I'm going to drag this out onto my -z axis. That is this axis here. You can see right here how it has the blue color that doesn't have the letter Z. That's how we know it's the -z axis. And I've found that this is forward for our character. So we'll keep it like that, and that should work for us. Now, for us to be able to move our character, we will need to have some way to navigate, okay? And the only way to really do navigation is to use the navigation server or to do a star, which in our case, we're just going to use Godot's new navigation server. I figured that this would be a fun way to teach us how to use the new navigation server. So if we head back to our test level and we right click our test level, we add an child node and we type in nav, you will see that we have all sorts of different options here. Now, the one we're looking for is the navigation region 3D. So we'll double click that and let's click bake nav mesh. And you will see, well, it just fails. And the reason why is because we don't have a navigation resource. So let's hit OK and let's come over to our nav mesh and add in a new navigation resource. Now, if we click on this, you'll see there was a bunch of options here. And all of these options are really cool. And if you guys want to know more about these options, I have a tutorial on Godot 3.5's navigation system, which is a carbon copy. It's a backport of this navigation system. So all of the information inside of there is valid. So just run through that and I go through all of the options for you. Okay. So now that we have our resource, let's click on bake. So we'll click bake and nothing will happen. Now, why is that? Well, the reason why that is because navigation mesh only works when objects are underneath the navigation region or a part of the navigation group. In our case, I'm just going to click this guy right here and I'm going to drag it underneath our navigation region. And then if we click on it and we click bake, you will see suddenly we now have a navigation mesh. Awesome. That's exactly what we wanted. Now, something you'll notice though is for some reason, it didn't cut out our little box here, right? Even though our box has collision, it didn't even recognize that it exists. And that can't work for us because we need our character to walk around that box, right? We need our enemy to actually walk around that box and not collide with it. If it's chasing after the player and the enemy's here, and the player's here, right now, it'll just path right into the box and then just stay pushing up against that box. And unfortunately, that doesn't work, right? We need it to walk around the box and go after the player. So how can we do that? Well, if we just drag this guy underneath here and then click on our navigation region and hit bake, bam, there we go. You can see it's now cut this out and it works perfectly. And that's basically all we need to do for our navigation to set it up so that way we can navigate, at least on the level side. So let's head back to our enemy. Let's hit Control S and let's save it. And let's go into scenes and name this as enemy, capital E. There we go. And if we put our enemy in our test level, so let's go into our scenes, let's drag our enemy out. We'll put them right about here-ish. If our enemy were to try to navigate, we can't because we don't have a way to interact with our nav mesh. And the Godot developers gave us a specific node to allow us to work with the navigation mesh. And that is if we right click our enemy and we add in a child node and we add in a navigation agent 3D. The navigation agent 3D allows us to actually navigate in 3D, hence the name navigation agent 3D. So we'll double click that and add it to our enemy, and that will basically allow us to navigate with our navigation mesh. So now we can come up here, we can right click our enemy, and let's attach a script. And this script's going to be called enemy, and we will click on our little file icon here, and then we'll peel up, we'll go to scripts, and then we'll hit open, and that will allow us to put it over in our scripts folder. Now, as a template, we could use a character body, or we could just use a node. In my case, I'm just going to use a node. It's just going to be a little easier for us. So I'm going to click create. You're going to see it's opening up our project here. And there we go. So first, if you remember, if we come back to here, we have 4 states. We have our patrol state, we have our wait state, our hunting state, and our chase state. So what we're going to do is we are going to make an enum for that. And an enum allows us to have a word to mean a value. Okay. So think of it kind of like saying if states, let's say we call our enum states dot patrol, then go do a thing. We could do that. Or we could do if current state is equal to 0, then go do our patrol code, right? The nice thing about enums is it allows us to have a word to associate a value. It makes it easier for our brain to work and understand what our code is doing. So I like to use enums for that purpose. So how do we create an enum? Well, first you have to type public enum, and you have to name your enum. So we'll name it states. Okay. And just like we discussed, we have 4 states, which is patrol, chasing, hunting, and waiting. And since we're doing a state machine, we need to house our current state, right? We need to know where we are in our states, right? If we're hunting or if we're chasing or something like that, the AI needs to know its state. So let's grab a reference for that. So we'll say public states current state. Next, we need to actually build out our state machine. So we'll come down to our process node, we'll hit enter, and we will type switch. We'll hit double tap tab, and that will automatically bring our switch up, and we will switch on our current state. Now, a switch statement actually is really cool because it allows us to do an if statement. So if, else if, right? It allows us to do that, but in a really well-formed manner. And I love using it for my state machines. So we'll come in here, and how we do it is we can just click and Visual Studio will automatically detect what we want it to do, and it's just going to do it for us. So it's going to make a case states.patrol, and then it's going to break. And basically how switches work is this case, it's going to check this value here. It's going to check for this value. And if this value is what the current state is, then it's going to run any code between here and here. And that's pretty much how we can do it. And if it's not this one, then it's just going to move to the next one. And it's going to go all the way down the line until it hits default, in which it is going to break. To kind of illustrate this, let's go into our patrol state here and let's actually build out our patrol state. So when we're doing our patrol state, we're going to be using the navigation system. So since we're going to use the navigation system, let's get a reference to the navigation system. So we'll scroll up here and we'll type public navigation agent 3D navigation agent. And like I said, Visual Studio is doing a lot of helping here to just kind of put stuff in. And then we can come down to our ready and we can hook it up. So we can say navigation agent is equal to get node navigation agent 3D, and we'll pass in our navigation agent 3D. So I believe we just named it navigation agent 3D, except for I believe we had a lowercase d. So we'll just copy and paste that. And then we can actually just set up our state. So we'll say current state is equal to states.patrol, and that'll set us up for patrol state. And then to do our navigation, we need to set a target location. So let's type navigation agent dot set target location, and we need to pass in a target location. Now this needs to be a vector 3, so we could technically make it whatever we want it to be, but in my case, I'm just going to go and fetch a bunch of waypoints because we're going to be walking from waypoint to waypoint to waypoint anyway, so we might as well just set that up. So let's head back to Godot real quick, and let's head over to our test level like this, and let's add in some waypoints. Let's right click, add a child node, and type marker 3D right here. We double click on that. A marker 3D is basically a 3D position point that basically just says this is a point in 3D space. So if we grab this guy, we duplicate him, we drag him down like this. We can take this guy, grab our node, go over to groups, and then just type enemy waypoint. There we go. And then we can do the same thing for this other marker right here. So we'll just copy and paste that just like that. And that should do it for us. So now we can head back into our C# project here, and we can go and set our waypoints. Now, it would be really good for us to keep track of all of our waypoints. So let's create a list of waypoints. So we'll come up here and we'll say private list of marker 3D, and we'll pass in and call it waypoints is equal to a new list of marker 3D. We need to initialize our list or else it's just not going to work. Okay. And we can also set our current waypoint. So let's just say private int waypoint index. Just like that. And that will allow us to have our waypoints and have which index we are currently on. This will come in handy when we do our saving and loading system. We'll be able to say, hey, what waypoint were we at? And we'll be able to also do things like keep track of which waypoint we're going to and things like that. So now we can just come into set target location. We can say waypoints, and we'll just pass in, for right now, we'll just pass in the first index. In the future, we might make this a little bit more flexible, but we'll stick with the first index here. And we need to get all of our waypoints and add them to our list. So just say waypoint is equal to get tree, get nodes in group, and let's pass in our enemy waypoint just like that. And then we need to, and now you'll see that we have a small error here. And this error basically says, hey, I can't convert a Godot collections array to a system.collections.generic. Okay. And this is not fun to deal with. So I found a really simple way around it. What we can do is we can use link. And if you've never used a link, it's basically magic. It's really, really cool. So if I hit dot and I type select SAAR equals to pointer SAAR as marker 3D dot to list. And that will allow us to basically select everything on our list, we'll convert it to a marker 3D, and then pass it back as a list. And you can see how simple that makes everything for us. And then we can set our target location to our waypoints 0 dot global position, and that will set our target location. And then we can just come down to our patrol right down here, and we can basically just start coding our patrol code. Now, first, we're going to want to check if we've finished our navigation. And if we have, then we can basically just say, return, right? Because we're done navigating, so we don't really need to do anything. But if we need to navigate, then first we need to get our next location. So we'll say var target position is equal to navigation agent dot get next location. And what that's going to do is it's going to pass us a location for us to move to. So one of the big things that's important to know is navigation is basically moving from one point to another point, right? And between those 2 points is a bunch of smaller points that we're walking to. So we're getting a target position, so the next point we're going to, and then we got to get the direction to that point. So var direction is equal to global position dot direction to target position. And then we need to set our velocity. So velocity is equal to direction multiplied by our speed, how fast we want to move. Now it's up to you on what you want to set it to. I'm just going to set it to 2 for right now. Actually, you know what? We'll actually come up here and we'll set it up here. So we'll just come up here and say private float patrol speed. And we'll come down here and we'll just say patrol speed. And I will set my patrol speed equal to 2, just like that. And we'll come down here and we'll make sure we have our patrol speed. And then we will set move and slide. And that will allow us to move. Now, if we've done everything correctly, in theory, this should work. Our little guy should move. So if we head back to Godot real quick, we hit play. He might move too quick for us to see him. So hopefully we'll see him. And he didn't go anywhere, but we do have lots of errors in our debugger. That's not a good sign. So let's hit F8, and that will actually close the Godot game. I didn't know that that was a thing, but somebody in the comments said, hey, by the way, you can just hit F8 and that will work. So really cool. Thank you for the suggestion. Now, if we take a look at our error, it's saying that it cannot find the navigation mesh agent. So let's head back to our enemy and let's take a look. So it's navigation agent 3D. It's a capital D. Did I make that mistake? I did. Oh, well, that's my fault. So capital D, let's try that again and let's see if that works. So let's hit crouch and you'll see that he's moving. Awesome. So now he's moving. Now, this is getting a little on the dark side, so let's go into our test level. Let's add in a child node, and let's add in a light, and let's add in a directional light. That way we have some form of directional light, and then I can just kind of pull this guy down here. And I'd like to have some shadows so it looks nice. So we'll click on our directional light, go into shadows, and let's enable that. There we go. That looks a lot better. It actually looks good. And that means that our enemy will actually, we'll be able to see what we're doing. But one of the big things that you'll notice is first, when we hit play, our guy moves, which is great. And he gets to here and he stops, but he doesn't do anything else. So what are some things that we can do to make this actually work better? Well, if our navigation is finished, let's change our state to waiting. You remember in our planning session, we actually said we'd set a timer and that we'd set our state to waiting. Well, if we look at our enemy, we don't have a timer. So let's get that real quick. We'll right click up here. We'll add a child and we'll type timer and we'll name this wait timer. And we'll come over here and set this as a one shot and we'll drag our idle time down to something like, I don't know, maybe half a second, maybe a second. How about a second? I think a second's a good number. And then if we come back to our script here and we set a reference to it, so private timer, patrol timer, and then let's get our node for our patrol timer. So patrol timer is equal to get node as a timer, and we called it patrol timer dot semicolon. And we'll come down here and we'll set our timer. So first, to set our timer, we'll just say patrol timer dot start, and that'll start our timer. And then we can set our state as waiting. So we will say current state is equal to states dot waiting. And there we go. Now we need to hook up our timer. So our timer is going to run, right? It's going to start it, but it's not going to do anything when it finishes. So we need to set up a signal here to get fired off when our timer is finished. So let's come up to our node. Let's go to signals. Let's right click our timeout and hit connect. Let's copy this guy and connect it to our enemy. And let's come down here and say private void on timer wait timeout. And then when the timeout happens, we can set our state back to patrol. But when we set our state back to patrol, we need to change our waypoint index. Now, we already have a waypoint index up here, right? Because it keeps track of where we are. So let's set our waypoint index to our next index. So say waypoint index plus equals 1. And then one of the big struggles that we're going to run into, and if you guys were to not do this, you'll find out real quick. If we don't check if our waypoint index is bigger than our array, then eventually we're going to run out of array elements because it's going to constantly be incrementing this value forever. So we need to check for that. So we got to say if waypoint index is greater than waypoints.count. But this would fail. And the reason why this will fail is because waypoints.count is going to come back with a value that's +1 of our actual index value. And what I mean by that is if we have an array or a list of objects, and let's say it has one object, okay? So we have one waypoint in our list. So we can say, okay, grab our count of our array, which means we have one item in our array, but its index is 0. When we want to call it, we say 0, not 1. So we need to make sure that we -1 to this value, so that way the waypoint index and the waypoint count is of the same base. It's base 0 versus base 1, if that makes sense. And if it is greater, then let's just go back to the beginning of our cycle. So we'll say waypoints index is equal to 0. And it gave me an extra space. I don't know why. And then we can set our next target location. So navigation agent dot set target location, and you'll see that Visual Studio is doing all the work for me, and it just basically did it. Waypoints, waypoint index dot global position. And then we can set our current state. So current state is equal to states dot patrol. And if we've done everything correctly, if I go back to Godot and I hit play, if I crouch, you'll see he walks to his location, waits for a second, and we have lots of errors. That's always a good sign. What do we got? So node not found, patrol timer. So if we head back here and take a look, patrol timer, let's take a look at our enemy. It's called wait timer, so that's my fault. I'm sure you guys were yelling at me, so I'll paste that. And let's retry that real quick. So we'll refresh this. Crouch underneath here. We're hiding from our guy. You'll see that he goes to his next waypoint. Awesome. So now we have a guy who can navigate from point to point. Cool. And that actually works if we use our, if we just keep adding more points. So if I come in here, I can actually duplicate this and add in a third point here. And if I hit play, you'll see he walks to this point. And then you'll see he walks over to his next point over here. See that? So that's how we can make ourselves some basic patrol movements. So now he's actually patrolling the area, which is awesome. Something else you'll notice is our enemy is not looking in the correct direction. He's actually not even paying attention to his path at all. He does not care, right? And that's a pretty big problem. We need him to actually look at where he's going if he's going to effectively scan the environment. So how can we make him face the proper direction? Well, if we head back to code real quick, go into Visual Studio here. If we come up to our patrol right here where we're doing our move and slide, just above our velocity change here, let's look at where we need to go. So what we'll do is we'll type look at, and we need to pass in some kind of direction for us to go. And what we'll do is we'll pass in a new vector 3, and we will pass in our target position.x, comma, and in our y, we don't want our y to get messed up. So let's type global position.y, comma, target position.z, comma, and we need to tell it which way is up. So we'll pass in a vector 3.up, and that should pretty much do it for us. So basically what we're doing is we're looking at our target position, so where we are headed to, the X and the Z axes, but we're keeping our Y, so looking up and down, we are keeping our Y axes the same. That way we don't actually look up or down, we only look basically left and right, if that makes sense. And then we have our vector 3 up, so we know which way is up. So now if we go back and we hit play, in theory, this should work. And there you go. He's now facing the correct direction. And if we let him turn, and he turns. Awesome. That works. See, there he goes. Now you see his movement is a little bit jerky, and I'm not a huge fan of that. So instead of making it so jerky, let's actually make this into a decent function here. So that way it doesn't just snap, right? So what we'll do is we will keep track of our last looking direction. So let's come up to the top here, and I'm going to minimize this little thing here. And I'll say private vector 3 last looking direction. And then we'll come down here. And what we'll need to do is, if we have our last looking direction, we need to basically do what's called lerping. It's where you take two values and they kind of change over time, okay? So first we need to create a new vector 3. So vector 3, looking direction is equal to our last looking direction dot lerp direction, comma, and kind of how long we're going to be lerping. So we'll say 2f. I think that's a fair value. And then we can just change our target position equal to x and z. And then we can pass in our last looking direction is equal to our looking direction. And actually, we need to lerp on our target position, not our last looking direction. That's my fault. And I should probably zoom in for you guys so you guys can see a little better, eh? For some reason, Visual Studio reset my zoom. So this should, if we hit play, it should work. So let's see how this goes. So if we hit if we crouch underneath here, and you'll see that he kind of snaps into position instead of straight up. He kind of turns, right? He kind of lerps instead of snapping, if that makes sense. Now, we could make this a little bit slower to make it a little easier. But you can see he actually does what we would expect him to do. He turns, which is great. Awesome. So now that we have our patrol basically completed, let's create our hunting system. Okay, so to do our hunting system, if you remember back when we planned our stuff out, we had two rings, our far hearing and our close hearing. And then we had two cones of vision, the close cone and the far cone, right? So let's head to our enemy, and we can achieve this by using what's called area 2Ds. So if we come up to our enemy, we right click it, we add in a child node, and we add in an area 3D. And area 3Ds don't work without having some kind of collision area. So let's right click, add a child node, and add in a collision shape 3D. And collision shape 3Ds don't work unless you actually have a shape to define it, right? You can see right here, a shape must be provided for the collision shape to function. So if we head over to shape and we click, we could just add in a nice sphere shape, just like that. And then we can just kind of pull this guy up and then expand it out. And we'll say his close hearing is somewhere in this area. And then we can basically call this one close hearing, just like that. And then we can take this guy and we could duplicate it. We can call this far hearing. We can come into our collision shape and we can right click and make unique. And then we can drag this guy out to something large, something probably about here, maybe even larger if we want. You want it to be large enough that he's going to notice noise. So just kind of drag it out to wherever you feel makes sense. And that will do it for us. Now, we also want to do our small cones that we have. So let's right click our enemy, add a child node, and add in an area like we did, and call this close sight. And then right click it, add in a child node, add in collision as usual, and then click on our empty. And then you'll see that there is no triangle shape, which is unfortunate, right? Because how are we going to do this if we can't use a collision shape or use a triangle shape, right? Well, that's where convex polygon comes in. If you click on that and you click on it, you'll see that you can have an array of points. And this only works if you have, usually 5 or 6 points here to create that three-dimensional object. So we'll create 6 of them, 3 for each point. And what we'll do is we'll offset the first 3 by 2. Okay? And then we can grab this guy and say something like 6 and 6. And I think that's the wrong direction. So we'll go with -6, -6. There we go. And you can see it kind of pops out like that. And then we can grab the next one and we can say 6 -6. And there we go. You can see it pops out like that. We're almost getting a triangle, right? And then we can come in here and say 0, 2, 0. We can grab this guy and say -6, 6. I guess it's -6. And then grab this guy and say 6 and -6. And there you go. You have yourself a very basic cone. And we can kind of drag this out to be in front of our character. And there you go. You have a basic sight line. And now we can grab our close sight, we can duplicate it and change it to far sight. There we go. We can click on our collision shape, click on our convex polygon, and let's right click this guy and make it unique. And then we can click on it, click on our array, and change this to something like 16, -16, 16, -16, 16 and -16, and one more 16 and 16. And there you go. You have a very basic sight cone as well. You could probably pull this one out just a little bit further, but I think that that will be okay. And basically how this is going to work is that we're going to have Booleans that says, hey, am I within this range? If so, then I can start looking for the player. Okay. And what we'll do is we'll hook up these signals. So with area 3Ds, they have signals here that are body entered, and that's what we're looking for. Is when a body enters this object, if it's the player, then let's start tracking that player. Okay, so this is going to take a second, but we're going to need to hook all these guys up. So we'll click on bodied enter, enemy, we'll copy this guy, hit connect, we'll scroll down to the bottom and we'll say private void paste, and there we go. And then we'll need to do the same thing quite a few more times. So let's just copy this guy. So on bodied exit, on body enter, exit, sight enter, sight exit, close sight enter, close sight exit. And now we can just come in here, close hearing, double click on the body exit, copy this guy, connect it, scroll down to the bottom, paste it, tab back, far hearing, body enter, copy this, connect, scroll down, paste, go back, on exit, copy this, connect it, go back, scroll down. It's a lot of manual labor, but it'll be great when we're done. So we'll connect this, scroll down, paste it, connect this, and last two. So grab it, connect it, scroll down, and last one. There we go. So now that we have these guys, basically we have our far, our close for hearing and sight. And now we need to set some Booleans up to determine if the player's within range, right? For the rest of our code. So if we head up to the top, let's create 4 Booleans, one for each different state. So we'll come in here and say private Boolean player in earshot far, and then I'll just duplicate these 4 times. Player in earshot close, player in sight far, and player in sight close. And there we go. Now, I know what you're thinking. Why not just make this an enum or maybe a state, right? Like a state system. But if we do that, then we may not be able to deal with some weird functions where what if the character's in sight range and in earshot, right? Do we track both sight and earshot? You know, one of the things about sound systems is you can see farther than you can hear a lot of times. So if you were in a state machine and you were saying, well, if they could see you, then they can hear you, then that's going to be a problem. But what if they can't see you, but they can hear you? Then does that take precedence over sight? And that's a lot of really weird states. So instead, just do 4 Booleans and it just makes it a little bit easier. Now, if we scroll down, we can start setting them. So when you are entering your hearing, you can type player in earshot close is equal to true. And then we'll just set this guy to false. And then on far, so player in earshot far is equal to true. And then copy that, paste it, false. Then we can come down to sight. Player in sight close is equal to true. And then just copy and paste it, false. And then player in sight far is equal to true. And I will copy this and paste it, false. Awesome. All right. Now, if we come in here and we GD print right here, because on far hearing, which would be this one right here, on our far hearing, if we GD print player is in far hearing, I forgot my semicolon. If we run this, you will see A, we're getting a bunch of debugging issues. B, if you look at our output, well, we got a lot of debugger issues. Error from signal body callable on far body. Method not found. Well, that's not good. Oh, I know what it's mad about. Because we don't have our node 3D. So we need to pass in a node 3D. This is something I wish that they had better error checking for. But I guess I don't really know how they would fix that. But let's pass in our node 3D object. Just like this. There we go. And then let's try running this. And you'll see that we have player is in far hearing, which is true. I mean, player is in far hearing, but we're also getting a lot of extra messages here. You see that? We have 4 of them. And the reason why is because if we look at our test level, we have our player, we have our box, and we have our other box. And then I'm assuming it's picking itself up as well. So it's saying that there are 4 things that it can listen to, which doesn't work, right? We only want it to pay attention if the player is within hearing distance, right? So instead of doing this where we are not checking for anything, we need to check to see if the object is the player, okay? So if we come in here, we can actually check for determining if the object is the player. So we could just say if object obj is player, then the player is in earshot. Just like that. Now, we actually can just grab this guy and paste it like this. And this one will need to wrap like that. But we can basically just paste this guy. And that's basically all we need to do. I mean, thankfully, C#, we don't need the brackets unless we're doing more than one command. So we can just do it like this and it will work perfectly. So if we come over here and hit F8 and then we hit play, you'll see we only get 1 player is in far hearing. So we can guesstimate that everything's working pretty well. If we wanted to, we could come in here and fire off player is, in far hearing, player is in close hearing, things like that. But I think we'll be okay. And we can do some fancy magic later to help with managing our state. So next we can set up our hunting state. So we now know if the player is close or if they are far. So now we can try to start detecting for our player. So what we'll do is we're going to create a function called check for player. And customarily I would just do the code in here. But since our chasing and our hunting code is going to be doing a lot of the very similar things. We're going to want to make sure that our code is reusable. So let's come down here and let's check for our players. So we'll say private void check for player. And what we'll do is we will do a raycast, okay? And the reason why we want to do a raycast is so that we can determine if the player is behind a wall. If the player is behind a wall, then we don't want to necessarily track them, because if they're in a different room, then the system shouldn't detect if there's noise, right? Because that makes it very unfair for the player because they're not directly there, if that makes sense. So what we'll do is we'll raycast. And the easiest way to raycast is to use the physics direct space state 3D. So we'll type physics direct space state 3D, and we'll just call it space state 3D is equal to get world 3D dot direct space state. And this basically pulls back our three-dimensional space state, which allows us to do raycasts. So then we're going to do our raycast, and we'll say var result is equal to space state 3D dot intersect ray, and we need to pass in a physics ray query parameter, okay? And what we can do is we can just create a new one, and we'll say physics ray query parameters 3D open parentheses, close parentheses. And unfortunately, they don't really have a constructor that's actually good inside of the C# version of Godot. So instead, we're going to have to initialize it using the getters and setters that are built into C#. So what we'll do is we'll hit curly brace, enter from equals get node, and we'll raycast from somewhere, okay? And when we raycast, we want to raycast from our head, right? From the enemy's head position, because that's where they would be most likely to see a player. If the player's crouched behind something, when it raycasts, it would have a higher likelihood of hitting them if it raycasts from the enemy's head. Now, we don't actually have a head node here. If we go to our enemy and you take a look at him, we don't have anything that really denotes the head. I mean, I guess you could go off of this mesh instance, but that's probably not the most ideal location to raycast from. So instead, let's right-click our enemy, add in a child node, and let's add in a marker 3D. And let's just kind of drag this guy up to about here, which is about where the head would be located. And then let's just name it head. Simple enough. And then if we head back to Godot, we can say node 3D, open parentheses, quote, head dot global position. Okay, and that's going to raycast from our global position. Now, you will notice that even though it's a marker 3D, I am saying this is a node. And the reason why is because marker 3D inherits from node 3D. So technically speaking, we can say it's a node 3D because it inherits from node 3D. So it kind of gives us a little bit more flexibility, and it makes our code a little bit simpler to read if we just see node 3D instead of marker 3D. It's up to you. It's kind of dealer's choice, but in my case, I just prefer having a node 3D. Now we're going to raycast to a location, and in our case, I'm going to raycast to our player. But if you look at our player, okay, and we look at our player object, you'll see that it's raycasting origin is located right here at the bottom of our character. And that's going to be a big problem when we raycast to our player, because our player's collision is above the actual point, if that makes sense. So it would technically never hit it. So instead, let's raycast to the camera right here. And the reason why is because that's where the character's head is located. And that to me is the fairest location. If the character is crouched, it's going to shoot a ray at the character crouched. So it's going to be down here. And if I raycast it when the character is standing up, when the player is actually standing, it's going to raycast up here. So to me, that's the most logical location to raycast to get the best chance of hitting the player. So let's head back to our enemy and say to equals, and we could just say get node and hunt down our player and go fetch it and things like that. But instead of fetching our player by doing a get node, let's just create a reference up here and say private player, and let's go fetch our player in our ready function. This will give us a little bit more flexibility because then we don't have to go and find our player all of the time. So we'll just say player is equal to, and we don't have a way to reference our player. So what we'll do is we will come to our player and then go to our groups and add our player to the player group. And that will allow us to come in here and say get tree dot get nodes in group quote player, and we'll pull back the first instance that we see. Now, we will probably never need to have a second player ever in this game. So I'm not really concerned about just pulling back the first index because it really is never going to happen, right? We're not going to have two players at any point in our game. And you'll see that we have this little curly thing going on, and it's saying, hey, we can't convert Godot node to player. So we need to cast it. So we'll say as player. And then we can scroll down here and say player.getNode camera 3D. And I believe we named it camera 3D. So we'll just pass that in. Dot global position, comma, and then we need to override our exclude filter. If we don't, what will happen is when we do our raycast, it's going to fire out and it's going to hit ourselves. So we'll hit ourselves and say, oh yeah, there's a player right in front of me. He's right next to me. But actually it ends up that it's just you, right? And you're raycasting and hitting yourself. So we'll need to exclude ourselves. So equals new Godot collections array, and we'll pass in this. And that will basically handle our actual exclusion. So it's going to exclude us from that raycast. And now all we have to do is we need to check if our result has anything in it. So if result.keys.count is greater than 0, then we can go ahead and do our code. So what we're doing is we're checking if the results we get back, if it contains any elements at all. So if we've hit anything, it should return something, right? And then here's where things kind of differ between Godot GD and Godot C#. Well, I mean, a lot of things have differed. I don't know if you've noticed, but one of the big ones that really kind of grinds my gears a tiny bit is we need to cast our results as a node 3D. So we'll say node 3D node is equal to, and here's where things gets weird, node 3D result collider. Now I know what you're thinking. Well, hold on a minute, Mitch. I don't understand the difference between this and this. One of the things you'll notice is that if I do this, you'll see this one has an underscore under it and this one doesn't. So why is that? Well, one of the things that's really interesting about C# is that we have the explicit casting versus implicit casting. And the big difference to an explicit cast, which is this guy right here, and an implicit cast is you are basically saying, hey, compiler, I believe that this is this object, right? And a lot of times it's really useful when there's an obvious reference inside of the conversion between the two. And an explicit cast, you are telling the compiler, hey, I know more than you do. I know that this is the object type and I can guarantee it. So just accept that this is that type. With an implicit cast, which is what this guy is, you are saying, compiler, I believe that this is a node 3D. If I'm wrong, though, come back as null. This one says, compiler, I guarantee that this is a node 3D. I know this is, and if it fails, it will crash your project. It also could lose data if the cast is to a lower base type. So for instance, if you were to take an object that is a float and convert it to an integer via an explicit cast, it could just lop off those back-end values and then just say, 1.3 is now 1 because you explicitly casted it to an integer. And if you implicitly casted it to an integer, right, it won't lose that conversion as much. It will fail to convert it and it will notify you that you did, but it will not crash your system, if that makes sense. So that's how I kind of understand it. And it might not be the exact correct definition, but that's the big difference. And if you ever run into this issue where it says, hey, you can't do it via reference conversion, boxing conversion, unboxing conversion, or wrapping conversion, then the simplest way to fix it is by explicitly casting it. Okay. So anyway, now that we have our reference to our node 3D, let's check if it is a player. Okay. So if node is player, then player P is equal to node as player. And we'll need to capitalize this P. There we go. And that will basically cast this node and say, yep, we've hit our player. We are good to go. And we can go ahead and do our stuff. Now, what we'll do is we'll create a nice if case here, just a big old bunch of ifs. And what we'll do is we'll check if our player is within our hearing range. And if so, we're going to print that they heard us. So if player in earshot close, then gd.print player in earshot close. And then we'll just kind of grab this guy and just duplicate it a few times. I know it's a lot of duplicated code, but that's usually how these things work. So if player in earshot far, then player in earshot far. If player in sight close, then player in sight close. And if player in sight far, then player in sight far. There we go. And basically, that will give us a good indication of if we are actually in sight of our enemy. So now we just have to call this function. So let's check for our player. So if we come up here in our patrol code, we can basically just say, okay, let's move and then check for our player. And it should be that simple. So now if we head over to Godot, we hit play. Player is in far hearing. Let's see if I move in close. Player is in earshot close. Player is in earshot far. If I head up, player is in sight far. Player is in sight close. And you can see that now we know our player is here. See? Simple enough, right? So now we know that our raycasting works. Our player is identified and our enemy can hear and see us. And also, if we come over to our game, which I had running, but I killed it, you can see I'm not detectable right now because I am behind this wall. But as soon as the enemy comes across this way, you can see how he can see me. And now we are getting all of our logs. And if I come back down here and I hide, he gets behind this, you'll see that our logs has stopped. And that's because he can no longer see us. But if I come underneath here, now he can see us. He is now tracking us. And that's the power of raycasting. And that's the nice thing, is that if our enemy logically could see us, then this bit of code here is going to run, which is perfect. That's exactly what we want. So now what we can do is we can check to see if the player is crouched. And if they are crouched, then we're just going to ignore them if they're far away. If they're closer, we'll be able to detect them and then we can start chasing after them. But if the player is just crouched, then we're not worried about hunting them down, okay? So we can come down to our code here and we can check to see if they are crouched. To determine if our player is in stealth, we need to check if they're crouching. And thankfully, we already have a reference to our player right here. So we can just check right up here and just say if he.is crouched, then we can do some code. Now, we don't really want to do it when the player is crouched. We want to do it when the player is not crouched, right? So we'll set it to not crouched. And what we'll do is we'll change our state to states dot, and if they're close, we're going to want to chase them, right? So we'll say states dot chasing. And then we could basically copy this guy, come down here and say if player is in earshot far, then our state is hunting. And then if our state is sight close, then we can just paste this. And then we can come in here and paste this, and you'll see it automatically knew what it wanted me to do. But if we look at it, if the player's in sight close, then we are chasing. And if the player's in sight far, then we are in hunting, right? He's seen us, but he doesn't quite know if, we are a bad guy, right? They're basically saying, what was that? Like, I thought I saw something, right? And that's kind of the usefulness of, that feature, I guess. Now, if the player's in sight close, thinking about it, we might not want to actually care if the player is crouched. They are right up on us, so you can definitely see us, right? And we could do the same thing with earshot close as well. We could say, no, if you're right up on this guy, he can hear you no matter what, whether you're shuffling or not. And of course, we're going to build a more dynamic sound system in the future. So this is all going to be changing soon anyway. So I'm not super worried about it, but I think this will actually work. Now, when we are hunting, the first thing that we need to do, according to our design, is we need to set our state to hunting, and we need to set our target location to where our player is located, right? We think we might have seen the player, but we're not really sure. So what we'll do is when the player is in earshot far, if they are not crouched, then we are going to say, hey, what was that, right? So we're going to set our navigation agent dot set target location over to our player global position. And we could set this to p.global position or player. It really doesn't matter. They're both basically the same thing, at least in this case. We can also do the same thing if the player is in sight far as well. So if the player is in sight and we are hunting them, then we can basically just set our target location to our player.global position. Now you could abstract this out to its own function if you want to. That's up to you. I mean, I don't really care if I have a little bit of code duplication, but some people like to pull this out and have an actual function for it. Now, since we're setting our state as hunting, let's head up to our hunting section here and our chasing section, and let's actually set up our code. So when we're hunting our player, we're going to need to move and and walk towards our player. So first we'll check if our navigation is finished, right? And if it is finished, then let's set our current state equal to waiting. Because if we're waiting, then we can just wait for a second, set our patrol timer like that, and then we can just wait. We know that we're done, we're good to go, and then we can just return. And that basically allows us to just wait and chill out. And then when we're completed, then we can go and continue back to our patrol. So basically, we didn't see the player, so we're good to go. We can just wait for a second, look around, and then head back to our patrol. But if we do see our player, we need to move towards our player. Now, here's where things are going to change a little bit. So you can see up here, we have movement code, right? We have code that lets us move. So we could just copy and paste this code down here, but that's a lot of duplicated code, especially since our chasing code is going to have the same thing. So instead, let's click on this little glass here, this little idea bulb, and let's click extract method. And let's name our new method move towards point. And we'll pass in our delta, and we're going to pass in some kind of speed, okay? And in our case, we're going to pass in our patrol speed. And I know that this is kind of preempting something, but I'm going to show you why this is important in a second. So we'll head back down to our patrol, our move towards point, pass in our double delta and our float speed, okay? And you can see here where we are moving our patrol speed. Let's change that to speed. And the reason why we're doing this is because it's going to give us a lot more flexibility. If we look up here, you can see that our hunting speed may be different than our patrol speed, and our patrol speed might be different than our chasing speed. So we want to make our stuff flexible if we can. Now, if we head down here, I don't think we actually need delta. I'm looking at the code and I think that will actually work. Yeah, I think that will work. So let's head back up here and let's grab move towards player, copy this, go to hunting, and just paste it. And there we go. We have our entire hunting state done that quick. It was like 5 seconds. And then if we want to do chasing, we can do the exact same thing. We can just copy this guy, come in here, paste, and change this from patrol speed to something else, right? So if we scroll up, let's grab our patrol speed. Let's copy that, paste it, and change this to a 3. And let's just call this chase speed. And then we can scroll down here and say chase speed. And one of the coolest things that we can do is we can come in here and just say, hey, if navigation is finished, then we can just attack. So we'll just say gd.print attacking. Now, in our case, I'm not going to build out a whole attacking system. I think we're probably about an hour, hour and a half into this tutorial, so I don't want to continue. I don't want to make this tutorial too long, but at this point, we should have a pretty full-featured system. Now, something we should check is right here. We are checking for player, and really, we shouldn't check for player every frame. It's just really bad practice. So instead, let's just say if player in earshot far, then check for player. And the reason why we want to do this is because if we are not in earshot, then there's zero reason to raycast towards the player. All it's doing is wasting resources. So now, if done correctly, we can come over here, refresh, crouch, and start moving, and you'll see that he doesn't come our way. But if I stand, so it's kind of working. So I found a quick bug with my testing. Something that we don't have set up yet is the ability to actually attack and kill the player. So what I'm going to do is I'm going to scroll up to our chasing state here, and I'm going to actually set our state to waiting, and I'm going to set our patrol timer to start. That way we just immediately go back to patrol, because I found if we get into the navigation finished, then we just get stuck in this state and we never actually leave it. And that's a pretty big problem, because move towards point actually runs our check for player, and if our player is away from our distance, then that's a pretty large problem. Now, something else that we should also check for is if we head to our chasing state here, we also need to set our enemy to chase after the player every frame. So we need to update that navigation location. So navigation agent.set target location, and instead of waypoints 0, let's do player.global position. And that way, every single frame, it's going to chase after that player and update its location whenever the player moves. Now, we could set this to a more lazy load. So like every second or every 10th of a second, it's going to update the target location. That's up to you guys on what you guys want to do. But in my case, I'm going to do this for right now. And then if we hit play and I come in here, you can see he just saw me and now he's hunting after me. You see this? Now you'll see that I just lost him. So he should not chase after me anymore. Let's see. There you go. And you can see he's gone back to his state. Just like that. And now if I stand and I move, you can see that no matter what, he can't hear me. If I get within his raycast, now he's hunting me. And now he just saw me, so now he's actually hunting me. So let's see if I can't get away from him. There we go. I think that will work. I keep seeing me because I'm way too bad at my own game. Man, he is good. So let me do this and let's run. And there we go. So now he's lost me and he's gone back to his chase or his normal patrol state because he's given up on searching for me. So that's pretty much the basics of our little game here. And next, what we'll do is we'll create a lighting system. So we're going to make this a little bit more efficient and a little bit better off for us, because right now it's not great. It's not bad, but it's not great, if that makes sense. And I want to make our stealth system as dynamic as humanly possible. So in the next video, what I'm going to do is I am going to build a dynamic lighting based stealth system. So look forward to that in the next video. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.